All right, let's take a moment to think about what we've seen and discussed. We've seen the structure of the next generation science standards, the nitty-gritty of performance expectations, foundations and connection boxes, and the philosophy of developing students' understanding of science over time. One of the 3 shapes in that next generation logo were the practices of science. This means performing experiments, using scientific tools, and creating experimental designs. And we find that research really does bear this out. Okay, so we've established that in order to implement the next generation science standards, you need a lab. What types of things do you need to consider in order to build and supply your lab? You'll need to decide who will select the science equipment. Will it be the principal, a science teacher? Who has the expertise to determine which scientific equipment to buy? How many pieces of equipment will you need? Will they be reliable, durable? The next thing you'll need to do is create the experiments, write lesson plans, develop performance and other assessments, and all of these will need to be correlated with the next generation science standards. Once the experiments, lesson plans, assessments have been designed, you'll need to spiral the concepts and experiments throughout the curriculum so that students learn the concepts multiple times in multiple grades with increasing complexity so that they develop their understanding of the science concept over time. In addition, you'll need to correlate the science curriculum with the Common Core Math and ELA standards. Or you can use what cognitive learning systems spent over a decade designing, developing, testing, and refining, the LabLearner science program. It has as its central focus a lab that can be installed in any elementary or middle school classroom, and includes lab tables, stools, and over 400 different pieces of equipment and supplies. Students learn science concepts by performing their own experiments, collecting their own data, and creating conclusions based on their own results. Units include concepts such as heat and heat transfer, electricity, and genes and proteins. The LabLearner program is designed so that scientific equipment is used and scientific concepts are addressed multiple times within a grade and between grades, so the concepts and science practices spiral through the curriculum. In addition, we've created over 1,000 correlations with Common Core Math and ELA standards. Here's another way to look at LabLearner and the next generation science standards. What you see here are the LabLearner units along the vertical axis and the next generation science standard core ideas along the x-axis. You can see that the LabLearner program aligns conceptually with the disciplinary core ideas of the next generation science standards. In addition, you see the right side of the matrix includes skills, analyses, and cognitive processes that are so important for scientific thinking. So in addition to just meeting the next generation science standards, you are developing a way for your students to practice science and think scientifically. This is why we call this LabLearner Next Generation Science Standards Plus. Well, we've finished looking at the next generation science standards. If you remember back, we took one example from a standard, but remember, all the standards are set up the same. So I think you'll have a really good idea of how to use them. Please feel free to share this video with your friends, and hopefully you're ready to get into your science classroom and go. But the way we can help you do that is through the LabLearner program. So please contact us at LabLearner.com. We'd love to bring a LabLearner lab to your school and help your students do science. Thank you.